All right, guys. So we are here, and we are going to dive into the code very soon. But let me first say that honestly, it hasn't been easy setting up this whole system for screen share. I think I've been on it for like 1 hour now, jumping from one issue to another. And to think that I thought I had already set up this thing before, and today I just came into my workspace and I tried to like get everything up and running, and I started running into issues again. But yeah, thank God we are here again. All right, so yes, before we continue, or before we start getting into the code, I figured, okay, let me show you guys the actual question, right? I'll show you the actual question first, and then yes, we'll move from there. All right, so let me look for the email because it was sent over email. So yeah. By the way, let me know what you think about my new glasses. I just got these glasses like a few days ago. So yeah. All right. So this was the first email, right, telling me that I passed the previous interview and I've been moved to the next one, and giving me an overview of what the next one looks like. So I think I shared this particular email like during that particular video when I spoke about my experience at Paystack. So yeah, so this is just telling me that the first stage of this assessment test is for me to familiarize myself with the technologies, right? And in this case, that was like Node.js, JavaScript, TypeScript, also MySQL, right? And then maybe GitHub. And then whenever I was ready, I would let them know and they would send the actual question. But I mean, in my own case, I already had like good understanding of this technology. So I just responded. I didn't capture my email because so just one line basically. So yes, and after I responded, I got a response, yes, that says fantastic. So let me read the question or the actual question. Your task is to build a small shopping cart application. Assume that you have a list of products in a category, um, e.g., food or clothing, which contains a set of standard attributes, skill, selling price, stock level, expiration, etc., which a user can add to or remove from and edit inside a cart. Please let us know if you have any question. So when I saw this particular email, I was like, okay, this is an open-ended question, right? So the first thing I did, let me look for it, was to ask clarifying questions, and that's one thing I would advise, right? That's a tip I give people. Once you get a test and you don't really understand exactly what to do, right? If there are some ambiguous statements or requirements, feel free to just send an email to clarify exactly what they need you to do. So I sent this email as a response. I said, oh, thank you. I will do that. However, I have a few questions or clarifications. They are listed below. The first thing I asked was, can I use any framework of my choice? I said on my choice. Sorry about that. Does it have does it have to include payments and billing, or can I simulate the checkout process? Can I assume there would be a user authentication module? Do I have to implement endpoints to create products and categories, or I can just write a script to seed the data into the application? Does it have to include the ordering module? Can I assume that the app would be exposing REST API endpoints? Right? I've seen people make mistakes by just like assuming certain things, right? So at times the questions that they send to you are ambiguous intentionally because they want to see your approach to it. And honestly, the first thing when you get an ambiguous requirement is to first clarify, right? You can see all these questions I asked. Some of them I didn't even need to ask them, but it would give that impression that okay, this guy is not just making assumptions. He tries to clarify requirements before just jumping into writing code. Some of us we are just so quick to write code. So someone will see this test now and say, "Oh, shopping cart. Let me just start writing shopping cart code." No, right? Try to clarify the requirement. So after that, I got a response. Can I use any framework of my choice? Yes. Does it have to include payments and billing, or can I simulate checkout process? Payment and billing is not necessary, right? I've seen it, and if I did not clarify this requirement, what I probably would have done, right, is that I might have actually built this thing, and that's what some of us do. We just go ahead and build something that they did not even ask us. Honestly, I've seen someone rejected because of that. Then can I assume that there will be a user authentication module? Yes. Do I have to implement endpoints to create those? Seeding is fine. Then does it have to include ordering module? Ordering module. What do you mean by ordering module? Honestly, I myself did not even know. So but I think at that time in my head, what I thought ordering module was that part where the user can. I think it was just the checkout process. Honestly, now that I'm thinking about it, I don't think that was a valid question. Then can I assume that the app would be exposing REST APIs? Yes, definitely. So yes, I got all these clarifications, and now let me show you what I did. All right, so now let me share my screen. Um, all right, so this is I'm sharing my big screen, by the way, my monitor. So I've had to increase the font size of my WebStorm. So yeah, I use WebStorm. I use WebStorm a lot. I mean, every time actually, except maybe my work system is acting up, then I use VS Code at times. So basically that's it. So where do we start? Where do we start? So obviously you know that this was built with Node.js. So I used Node.js, TypeScript basically, right? Because I mean anyone would favor TypeScript over JavaScript. So yeah, I used TypeScript for this. I think I used MySQL for the database. Um, Let me see what else. What else I used. What else did I use? Oh yes, I use class validator. For those of you that don't know, class validator is a library that is used for validation, right? And is mostly used with TypeScript. I don't think I've seen anyone use it with JavaScript. So it's used with TypeScript. Is I prefer it to Joy, right? Joy is like I mean, I think it's more common than class validator, and I got to know about class validator when I started writing Nest.js, right? So yeah, I used bcrypt for, I mean, password hashing. I use .env for environment variables. I use email.js for the email part. And I use Faker when I was seeding data, right? And I think I also use it for my tests. And then I made use of Redis, super test for, what was it called? Super test for test, actually, for integration tests. Winston for logging. Then Sequelize. I think I was specifically told to use Sequelize because otherwise I would prefer type ORM. But honestly, in my experience, you should be able to use any ORM you're asked to use. There's this new one I heard about recently. I think it's Drizzle. I actually plan to like check it out. Maybe I'll just make a video of that also. Um, all right, so let's get right into it. So I think I will start from. So we know what the problem statement is. We have to build a shopping cart. We don't need to add any billing or payment, no checkout. So it's basically just the shopping cart part that we are building. Um, all right, so let's see. All right, so let me first say that when I thought of this project or this thing, the shopping cart thing, right? And you will see when I get into the actual code. I actually stored the cart data, right, inside Redis and not in the database. Now that I think about it, I'm like, okay, why did I do that? Honestly, at that point in time, I think the thought process was that, oh, cart data is temporary anyways, so why do we want to store it in a database, right? If we would have to like remove it eventually. And also because I felt like storing is in Redis will give us like lower latency in terms of reading. And yeah, I just felt like Redis was much better than storing it in database. And honestly, during the interview process, one of the interviewers asked me, okay, what if we now want to have some kind of analytics, right, based on the cat data? And then I was trying to find like some brilliant ways to implement it using Redis, and we had back and forth, back and forth. It started adding requirements, added no, started adding complexities, and eventually I was like, okay, if I knew this, right, I would have actually used MySQL. So yes, so I would say that, and honestly, if I'm to build an e-commerce system right now, I'm going to use MySQL. I'm going to use a database to store the cat's data, right? But the point I'm trying to make is that even though I won't use Redis right now, right, because I had a reason for using Redis then, right, and I mean the reason was not the best, but at least I had a reason, and I could defend my decision. So that's another thing I would like you guys to just take note of. Whenever whatever it is, it's not really, at times it's not really about the right way to do things or the best way to do things. It's about the right way, obviously, but it's not about the best way to do things. At times, you might not do what is best, but as long as you're able to actually explain your thought process and it makes sense, I think that is good enough. So, I talked too much. So let's get into the. So I'll walk you guys through the file structure, and then we'll start getting into the actual files. So as you can see here, so we have like the config folder coverage. Coverage is only here for test. It's a folder that is created by Jest whenever I run the tests. So you have config. Config stores like database. I said database environment configurations basically. And in this case, specifically for the database. Um, Thinking about this, I'm not exactly sure I used this file honestly, but let's we are going to find out actually. So yeah. Then there's a database folder. I mean, I call it DB, which contains the migrations, the models, and then the seeders, right? So I think I'll just walk through the um, okay, let's check the file structure first. Then the dist folder, obviously, if you are running TypeScript, right, you need to have a dist folder because whenever you transfer the TypeScript to JavaScript, right, the resulting folders are stored inside the dist folder. I've seen people use build also, so you can use any name, but conventionally is dist or build, right? So then there's a logs folder that stores logs. Basically, I don't know why I added this. Then node modules. Then we have the source folder. Then we have the tests folder. Then environment variables. Then I added this environment env.sample just so that it will be easy to clone and like run the application. Then ESLint obviously for linting. I don't know why I had this Git attributes. I think it was added by my by WebStorm then. Then git ignore, this stores every file and folder that we don't want to push to Git. Prettier, this is just for making your code look nice. Then Sequelize RC, this one is like a config file for Sequelize. Sequelize uses this to make decisions, right? As you can see, we have config parts, we have model parts, CDAS part, and the rest. Then package.json basically stores all our dependencies, right? And both the dev dependencies and the actual ones. Then it contains some configs for tests, right? Because I used Jest, that's why you can see Jest here. And then we have scripts here also. You can see start dev here. I saw the start dev when I started working with Next.js. So pretty much I used this because I was used to it um, when I was using Next.js. And then package lock, this basically just stores like every package and its own, it maps packages to their own dependencies, basically. I'll come back to this README file. And then I have a setup.sh. There's nothing special about this setup.sh actually, right? The whole idea is just to have a single point of entry where something you can use to basically set up the whole app. And then once you run this setup.sh, the only thing you need to do is just start the application, right? So that's why I just have this there. Then tsconfig contains configuration for TypeScript and how to convert to JavaScript. So for the README, you can see my README shopping cart application, Paystack assessment tests. So I added the requirements. I tried to make my READMEs as comprehensive as possible, and also depending on what the requirement is. At times, some companies will tell you to add a link to your documentation and add some other information there. So here I just have like requirements, the things you need to have on your system to be able to run this application. And so I added Node.js. I even added how to install it. I don't know who sent me, honestly, but I actually added this, and it's here. Then MySQL, if you don't have it, you can download it. I added Redis because I used Redis. And then I added details on how to clone, right? So you can clone it, and from cloning, you need to create an env file, copy the content of the sample env into the actual env, replace the database credentials, right? The whole idea of this step-by-step information is so that when someone wants to test or when they want to review my code, they should not have any issues, honestly, right? And that is what we should aim for. It makes things easier for the person that is going to review your code if like they don't have to like figure out how to set up your code or your project by themselves. Just give them every information and make it easy, right? Then you can also you should also set the email credentials. And I mentioned it here that test will fail if this is not done, right? So if they happen to run the test and it fails, then they would know that okay, this guy has warned us. Then create the database. Yeah, exactly. So you need to create database because I'm not automatically creating that database from the code. Then I ask them to run the sh file, the setup.sh, and in case you get a permission error, you can run this to grant your user permission. And I also mentioned what that file does. Now I also added like the assumptions I made, which is from the clarifications, right, from that email that I showed you guys at the beginning. So, and that is that only cat module is to be implemented, right? And then basically you can run it basically. And then yes, so design and implementation decisions added that cat data was stored in Redis for faster access and better performance, right? In this scenario, I was not accounting for analytics or reporting situations, right, or reporting cases, right? So, all right, so let's get into the actual code. So yes, like I said, this config.ts stores config environment variables for SQLize. So let's start from the source. Um, so this server.ts is the entry file, obviously. My assumption is that for people that are very interested in this code, right, you have like basic knowledge of Node.js and TypeScript, right, or maybe JavaScript. Then, so I won't go into the nitty-gritty details. So app.ts, so like I said, server.ts is the entry point. Server.ts imports the app from this app.ts. And there's a reason why we separate app and server. And that is so that whenever we want to run integration tests, where we have to make a request to the actual server, we don't need this. We can write our own dummy server with using supertest. Supertest basically creates a dummy server out of your app. So that's why we separated the actual app and the server, right? So yeah, so this is very straightforward actually. You will see, I mean, this is Express. I have a database service, which is, so this is basically like connecting to the database, right? So if you open this, it comes to utils. So I have utils, then database. So basically this is just connecting to the database, right? Yeah, as you can see, just connecting to the database. And then what else do I want to mention here? One thing you see here about this logger is that so I have a Winston logger service also, right? And I'm passing this database service as scope, right? The reason for this scope is for every log, we should be able to know where that log is coming from, right? And that's why I added that scope thing. Um, all right, what else? And you can see that I'm logging, right? I mean, when it comes to production level code, you don't want to rely on console.log, right? You should have a custom logger. And the reason for this is so that you can your logging service or your logger service can be customized to log maybe into a file or log to Datadog or any log aggregation service that you use, right? So yeah, that's that for database. We connect to database and then the port thing, whatever, and then API. That's it. And then you can see I have an error handler here, right? Which is a middleware, right? If you've written Express, you understand what a middleware is. So yeah, and you also notice that I use this HTTP status library or package, right, for my statuses. Um, I mean, I've seen people just write an in-house. You can just write it by yourself, maybe expose an enum, right? That does that. But honestly, I don't know. I don't know why I didn't do that because now thinking about it, I don't know. It's a little overhead, but there's this overhead of installing the package first and then accessing the file in the package, and that is, I mean, not as fast as just having that code in your project. But honestly, I think the overhead is negligible. So if you want, you can use it. So the whole idea of this is any error that is thrown, right, from the API or from the logic we have here, right, is going to be caught here, right? And the way you would know that this is an error handler, right, is by looking at the structure here. A normal middleware will start from request, right, down to next. But whenever a middleware starts from error, it is definitely an error handler, right? So yeah, that's that about app.ts. What else? Let me walk you guys through the utils folder. So let's check the utils folder. So in the utils folder, we have bcrypt. So and all this bcrypt service is doing is just it has like I mean hashing password and comparing the hash, right? And you can see that I wrap it around, I wrap it inside the try and catch just in case. Honestly, it shouldn't throw an error, but just in case it does, right, we should be able to catch that error. And this basically cascades, right, that error. That's all it's doing. Resolve and reject, right? They are promise functions, right? They just cascade the error so that, and the assumption is whatever it is that is calling these functions, right, would also have like a try and catch. So thinking about it now, I think, I'm not sure if it was necessary, right, having this, because if we are not, the only reason why it will make sense to do this is if I'm actually like throwing like say a custom let's say something like this HTTP exception. It's a custom to say unable to compare password, something like this, right? That's the only reason why I think this makes sense. But since it's just the same error object we are throwing, I think it would have been okay to just um, have this outside the try and catch. So yeah. So then we have a config service. As you can see, my config service, first thing I did was create an interface, right? And then I create a service, right? So this is so that I don't have to couple services to services directly, right? It is called tight coupling, right? When you connect two services directly together, right? So yes, that is what we have here. And the whole idea of this was from Nest.js. If you have used Nest.js, then you know that Nest.js config service basically works like this, right? You can pass the property you want to fetch from the environment variable, and you can set a default one. Then, as you can see, there's this thing I'm doing here where I'm saying that I have a get instance, right? If the instance already exists, right, it returns it. If not, it creates a new one. The whole idea of this is to make sure that the config service, right, is a single thing, so that when you are calling config service, we are just returning just one single instance, and that's what I'm doing here, right? Um, by the way, if there's anything I discuss here that you still like would like me to like explain more about, please just drop it in the comment section, and yes, I'll consider making some like strictly technical videos just for you guys. So we've checked the database. This one is just storing the types of DBs. Yes, types of DBs we can have. Then email service, like I said, I also have an interface for this. And then this is the email service. So I used email.js. Right now, I'm not even sure why I did, but I just wanted something that was simple enough to be used, right? So yeah, that's basically what this one is doing. I have a class. I initialize the client here, right? And I passed the environment variables here. One other thing you will notice is that I think for most of the functions I write here, I added documentation, right? So it displays like this on WebStorm, which I like. So yeah, that's it. So this is what happens when you throw an error. I'm sorry, when you send an email, right? It just sends it basically, and I used Paystack, whatever. Yeah. What else do I want to mention? One thing at the moment, I'm not really a fan of chaining, what's it called, arguments like this. So I prefer to have something like this now. Um, say data, right? Because it's just, it becomes unpractical. Impractical when you just continue having, what's it called? You continue having like 5, 6, 7 parameters. So for me, if like it's more than two, I just convert it into an object. So, but all right. So that's that for email service. Then I have an exception, right? So this is you must have seen somewhere where I think did I throw an exception somewhere? But I'll show you where I throw an exception. So this is basically just an extension of the normal error class, right? With my own additional attributes or property, which is status. The normal error class in JavaScript doesn't have status, and that's why I created this HTTP exception so that I can add the status code, right? So that's that. JWT, signing and verifying tokens, right? Logger. So I have a logger interface, and I have a logger, right? So I used the Winston um, library here, right? And this is what it looks like. One thing I like about the way I implemented this logger is that if tomorrow I want to switch to Morgan or Pinot, I just have to like create a Pinot logger or Morgan logger that implements this same interface, and we're going to be good. Then yes, middleware. So I have an authentication guard, right? Which basically just for every request that comes into the API, it validates, authenticates the request, and yeah. So as you can see here now I pass in the user service and the JWT service, right? And basically that's what it's doing here. Now that I'm seeing this, one thing I could have done differently, because I don't need this. I just have to. There's a way to. There's a shorthand version, right? So we can just do private read only, and here we do a private read only for this also. So it's like a shorthand version of what I did initially. So this one is not needed, and it's basically still going to work. So yeah, so authentication middleware. So I have a validate request function that basically it checks the authorization header. If it's not there, it throws an error. Then it checks whether it's a bearer token, splits it, and then verifies. Once it verifies the token, then it also tries to, let me see what this one does. Yeah, it tries to make sure that the user actually exists, and if the user exists, it stores it inside the request in the request the user. Now that I'm looking at this one, right, I feel like now I prefer my code to be something like this, right? But yes, I know it would have thrown an error, right? So one thing we can probably do here is, I think I can do maybe and something like this, right? Why is this throwing an error? It's not assignable to type. Oh yeah, and okay, and that's because of this request handler. This request handler is expecting a request, what's called a request type here, right? So that's why we'll not be able to do this. But if we remove this, basically, I mean, we are going to be good, honestly. So yeah, that's it basically. But let me just revert it back to what I had. So I think that was probably why I did this, right? Then another thing you can do is actually like create like an update for the normal express requests class, right? So it's like an update where you create a new definition class and you add it to the requests class, such that the request class now has like a user object. So yeah, that's something I've done before, but I don't really like doing it. So yeah. So we've checked the error middleware, and then validator. Now, what this does is validates payload, right? Basically validates payload. That's what I'm doing here. As you can see, I'm using class validator and also class transformer. So again, don't forget, if you have any question, just let me know. Now that I'm looking at this one, I mean, we have just done this, right? Because then this is the error dot length. If it's 0, then that will be false. It will be falsy. I mean, in JavaScript. Um, all right. So for any error, basically, it throws that error or it nexts it. So I mean, it throws the error, defines a new error, then it passes it into the next function, right? And from this next function, it goes to the error handler, because I mean, this is an error. So that says, please let me know if you need me to explain something. Then we have Redis service, and this basically makes use of Redis, right? I think, let me see if I did what I was thinking of here. Yeah, just makes use of Redis. Look at this now. Here I made use of console.error. I should have used the logger. I think it was an oversight. So I should have used the logger here. Okay, so that's that. Events, yes, this is for events handlers, right? Event emitters in JavaScript. And yeah, this is like a basic implementation of it. I will show you guys how it was used. So yeah, that's it for utils. What else? For constants, let me clear all this first. So for constants, honestly, I'm not really exactly sure why I did this, but I guess I think I just wanted to, I mean, I wanted the code to look fancy. So yeah, so this basically just stores most of the, I think every single error message in this code, and the same thing, this stores the success messages. So yeah, this is nice if there are situations where there are certain error messages that are like used multiple times, right? So you don't repeat yourself. So that's it. What else do we have here? Interfaces. So I created interfaces. Yeah, I made use of interfaces a lot. I'm not sure why this is here. I'm not. I'm not interested. So interface, cart interface, product interface, product category, then response. Right. So I have a. Oh, okay. Where is this thing? There's something I was looking for. I'm not sure where I put it. Then okay, it's not here. So I think I just created an interface for my responses, right? So for me, I like both my success responses and my error responses to have the same structure. So so that's why I have this. So you can see status can either be success or error. All right. So user interface. I think for me, the reason why I created an interface here is because of SQLize. I probably would not have like had to like create an interface if I used TypeORM, because TypeORM has like, I mean, class entities, right, which are basically classes. So, but at the time I used SQLize, right, at least I did not know of how to like create a class using SQLize. So yeah, so I made use of what's it called already? I made use of interfaces. So there's something I'm looking for. So for the DB, let me show you the models, right? So I have a product model, and I mean, as you can see, we have the ID, the name, these other things, right? And a product has a category, right? And I mean, it references product categories. So yeah, I think that's it. And this is where we are defining the association between products and product category. Then we have the product category here. Um, yeah, pretty much it. That's it. I mean, now that I'm looking at this, I think there's a class here. There's a product class here, but I think this product class has a lot more than what I needed. That's why I created an interface. So the same thing with the user. So my assumption is that at least you need to be a user to be able to add something to cart. So yeah, so I just added some basic information here, and that's pretty much it. In a scenario where we actually like stored the cart data in the database, then we would need to have maybe um, the cart table, right? The way I like to structure it, I like to have a cart, how do I put it? A cart table, then a cart items table, right? Yeah, I mean, I think that's for another video. I think that's, yeah, another video. So this is just like migration files. To This is to create a new user, I mean, new user table, a user table, actually, not a new user table. To create a user table, this is to create a product category table, and then this is to create a product table. And then after that, lastly, on the database side, we have like the seeders, right? So yeah, I needed to seed users. So as you can see, I used Faker to generate information, right? And I made sure to use Melinator. You can use any other thing, but I used Melinator because I wanted to be able to get emails. So so you can see I created a Paystack user. The reason why I created this Paystack user was because I think I specifically used this user in the test. So that's why I created this separate from this one, right? And then yeah, then seed products categories, right? And you can see here that I created just 5 categories, right? And then for the product, if you check the category ID, I'm basically just randomizing it between 1 and 5, right? I mean, it's just a wild guess. Because I made sure that, I mean, categories are like from 1 to 5 because the IDs are auto incremented. So that's it basically. Um, by the way, this code base I'm showing you, if you check my GitHub, I'll try to maybe add it. Hopefully, I remember when I'm editing this video. I'll just add it somewhere. I'll add it somewhere in the. I'll add it in the description, and also I'll just add it somewhere here so that you can access it. So yeah, that's it. That's that for that. What else do we need? All right. So let's just walk through. Okay, let me just show you guys the repositories. So for repositories, I created a like an interface for a base repository, basically, right? Because as at that time, there was no repository class or concept in SQLize. It existed in TypeORM, but not in SQLize. At least I did not know if it existed. I didn't know about it in SQLize then. So I created mine here, and then for the product repository, you can see I added like, I mean, a custom function, and then is extending the base repository, which is now a generic. for you guys that know what generics is. So a generic is just a way to like accommodate multiple things, right? So as you can see, this T is representing a type, right? So a type that you can pass as an argument here. Then user repository, the same thing, right? One thing I actually would have I'm doing now, right? Because then I was a fan of like create a repository for every single thing you need to do. So if you take a look at this, you will see, so you can see get user by ID is a function, get user by email is a function, get user by display name is a function, right? Now, if I would do this, I will not write three different functions. I will just write a get user by criteria function, right? And I'll be able to reuse it multiple times. So I think this is just unnecessary. But pardon me again. So then the actual repository, yes. So this one now implements the I product repository, and then you can have your function there. The same thing, the same thing, the same thing. As you can see, now that I'm looking at this one, I did not use the find all and save functions, right? So when it comes to OOP, there's a better way to have handled this because, right, there's a particular concept, right, that talks about having not having making sure that a class does not have to implement functions or interfaces that they don't need. So in this case now, this product repository doesn't need this find all, right? And this save, I think, yes, interface segregation principle. Yeah, it's part of the solid principles. So yeah, you can look it up, right? So there's a better way to do this, but I won't mention that in this video. All right, so user repository, I mean, does basically the same thing. We have the functions, we have, I mean, they're here. So yeah, let's walk through the flow. So start from the routes. So there's an index route that basically like exposes every other route. So yeah. So we'll start from the auth. So the authentication route. So one thing that you see that I did here in this code is, so you can see all these things I'm doing here, right? So we have the authentication controller, the auth controller. Now let me open the controller actually. Let me just do that. So let's go to the controller. So one thing you see about this controller is that the controller is actually taking in the service as a dependency, right? The whole idea of this is so that we'll be able to easily swap out the service, the auth service, if we need to, right? So let's say tomorrow we want to create another auth service, right? And we want to like do something different. So right, what we can do is for this auth service now, what we'll do is we'll create an interface for it, then create the new one, implement that interface, and then in fact, then this will not be say I or service. That's how I should have done it actually, right? Then by the time we are passing it in here, right, the auth service we are creating here will be the new one, and we are going to be passing that here. So that is so that we don't have to touch every single part of this code, right? I mean, there's a way a higher level where you don't touch the auth service, the auth controller at all, right? Even after that, there's a higher level where you don't even touch the route, right? That's when you use an IOC container. So the IOC container will basically like um, manage the dependencies, right? But that's a video for another day. So yeah, so what I'm doing here is basically is called dependency injection, where we are injecting the dependencies into the classes that need them, right? So you can see I created the user repository, the logger, the bcrypt service, then the JWT service, right? So yeah, and then the service here, the auth service, and we are passing the repository, sorry, the dependencies, right? And then, so if we want to switch to Pinot Logger, this is where we're going to do it, right? We don't even have to touch this one. So yeah, so that's basically it. And then we have the functions. I mean the routes, I say functions. So for login, for instance, okay, let's start with register. For register, Did I do something here? Okay. So for register, this is already becoming a long video. Uh, all right. Let me see if I can finish up early. All right, so for register, one thing you will notice in this code is the controller is actually very lean, right? And that's something we should aim for. Controllers should be lean. The thing, what controllers should do, hold on, yeah, like all controllers does, all a controller does is number one, receive the requests, number two, validate the payload, number three, call the necessary service, then number four, return the response. Honestly, if your controller is doing more than these things, I think you are doing something wrong, right? You can check online, you can read about having the about the controller service concept or architecture or the code structure, right? So that's all I'm doing here. Actually, my validation is happening here, right? I think I should actually move them into the controller, but it's fine. Okay, so why is this here? Is it repeated? Okay, so yes, like I was saying, right? All my controller is doing is just validation, calling the service, and just returning the response. Um, all right, and that's the same thing for every single thing here. And then yes, it handles errors too. So let's look at the service. Yeah, so this is the code for the service. You can see it's very simple. I hope it's readable. I mean, up to your own standards. That's what I was able to write then. So yeah, you check the email, you check the display name, you create the hash. Um, yeah, new user equals to this, right? So as you can see here, right? So I created the new user actually, and then returned true. I don't know why I returned true. Actually, now I'm thinking about it. Why did I return true? Why did you return true? Ibini, why? I don't think it makes sense to return true. So let's check login. Basically login checks the user, logs in, compares the password, generates the token, and then I generated the login response, which is, let me make this one stay here, which is this. It's basically just token and the display name, right? There was no requirement for login or any of these things, right? I did not need to do reset password, so I won't go, I will not go over that. So, so that's that. So let's check the cat route. So the cat route, as you can see, we did the same thing, right? Initializing the dependencies and then passing them into the service and the controller, right? So we needed the user service, right? Hold on. So where's the, why do we need the user service actually? Okay, we needed user service for the auth middleware. Exactly. So yeah, yeah. Okay. So yeah, and we've checked this auth middleware before. So yeah, good on that. Then yeah, cat controller. So you can see I created a new instance of Redis here, and then we are passing our product service into the cat controller. So let's check the cat controller real quick. Oh yes, I was going to show you guys this, the validation, right? You can see that all we are doing for this validation is we are calling this validator middleware, and then I passed there's a class. So the way class validators work is the way class validator works is that you basically create a class, right? And that's what I like about it. There's this structured pattern to it. You create a class and you make use of decorators, right? So you give is defined, is not empty, is a number. So if it's not defined, right, it shows an error. If it's empty, it shows an error. If it's not a number, it shows an error. And you can actually define the error messages. So error messages, something like this, right? I didn't do that in this case, so I'm just going to leave it. So that's how class validator works, basically. Quite very straightforward. And maybe one thing I would do differently is not name it validate body. I think I'll just name it validate payload, and then aside the type, hold on. So aside the type here, I think I'll just do this will be class instead, and then this will be type, right? This type will then be something like hold on, where is this? Why is this? Oh, sorry. Okay, I don't. This is going to be like body query, something like this. Oh, okay. Class is a reserved word. Sorry. Um, I'll just say payload class. Exactly. So we'll do something like this. So that we can validate the body, validate the query, maybe even validate header or whatever it is. We can validate params, right? I think we can validate params too. So yeah, that's basically what we have. Oh no, not yeah, it should be this, right? So and then this should be payload class here, and then hold on. So this won't be request dot body. This will be request at as type, right? So that's how that will work. But obviously that's not what we did, or that's not what I did. Why do I keep saying we? That just shows that I'm a team player, guys. I'm a team player. All right, so that's that. Then yeah, so when if you call add to cart, so you can see here that I'm fetching the current user, and then uh, hold on. Okay, then calling add product to cart. So we add product to cart. So you can see what I'm doing here is I fetch the product, ensure that that product exists. The reason why you're not seeing me throw an error here is because I already throw an error from the product get product from the product service. So if you try to fetch a product and it doesn't exist, right, I throw an error. And also I feel like I might be overdoing it here, or I might have overdone it here, right? I was trying to separate out when there's a database error and when the product is not found. So yes, that was my thoughts then. So and one thing I would do differently here, right, is instead of throwing an error here, I won't throw an error here actually. I'll just return whatever it is, right, and handle it however I see fit here, because that's so that you can make use of this function multiple times and handle them however you see fit, right? So yeah, so because there are times that you might actually just want to call this function, but you don't want to throw a not found error if the product is not found. You get so yeah, then I check if it exists. I mean, sorry, if there's enough quantity, then because I'm storing it in Redis, right, I need to generate a cat key, right, for the user, right? So the idea was that every user will have like a cat object that is stored in Redis, and there's a key that is being used to store the cat object. And I used this function to generate the cat. Where is it? This one. Right. The reason why I did this is so that whenever I want to, or if ever we want to change the way that cat key is generated, we don't have to touch existing code, right? And also because this function is being called multiple times. So then I get the data from Redis, right? Um, Yes, because Redis stores it as a string, right? Even though we are storing JSON, right? No, Redis will store it as a string. Even by the time we are storing it in Redis, we are stringifying it. So whenever we get it back from Redis, we have to pass it back to JSON, right? And then I check again console.log here. This should be normal logging, which I don't even think we need this. Then cat data is here. If it doesn't exist, right? We create because we're adding a new item to cart, so we create it right with the new cart inside of it. So that's what I did here. And then if it exists, I get the existing one, and then I still do some other things. I run some new checks, right? Because if actually, don't let me get into this whole logic thing, right? But I think it's pretty straightforward. I'm trying to make sure that the quantity that is in the cart plus the new quantity that is being sent, right? If you add them together, is less than the quantity we have in stock, right? So that's the whole thing that is happening here. And then if there is no issue there, all I do is just increment the quantity and I set it back. I push it back into Redis. Then that's it. So what's this? If product, if product cart item. So if the cart item exists in the data in Redis, so if it doesn't exist, then we just push it inside. Exactly. So then to get user cards, I use that cart key again. I fetch it from Redis, right? So exactly. So I do pass to data. I mean pass to JSON, or because if after passing to JSON, if it's undefined, then I default it to empty array. So that's it. Then there's a function that I use to convert it to the actual cat object. Oh God, what did I do here? So let's come back to this function. Then clear user cat, that's basically just clearing it up in Redis. Then remove product from cart. The same thing, right? You use the cart key, get the cart item, and then filter it out and store the remaining ones. So yes, so this generates cart item, no, generates cart user object. This is the object that is returned to the user, because you know that what we're actually storing in the cart, for instance, let me see, what we're storing in the cart is not, so cart item is what I'm storing in the cart, and cart item basically is just the product ID and the quantity. That's everything. So if we want to return the data back to the user, we can't just return the product ID and the quantity. So we have to like return the other details of the product, right? So, and that's what I'm doing here. I'm iterating over the items, right? And then I'm getting the product ID, fetching the product, right? And then creating a new instance of the cart item response, which is this function, which is this class here. So, and that's what I'm doing here. Yeah. So one thing I would do differently, looking at this code, let me see. One thing I'll do differently, I think, is that number one, it's number one now, or just the other thing, I'm not sure. I don't think it makes sense to call this in a for loop, right? So there is definitely a way we can use one query, right? So because what happens if that person has like, I mean, it's unlikely that someone will have 20 things in a cart or 50 or 100 things. But even at that, right? If we can reduce the number of queries or the number of trips to the database, right? It makes sense to do that. So what we can do here is have a function that says a service function, whatever, that says that get products by IDs. So it will be something like this. Let me do this. We get products something like this by IDs, and what we have, it will be what we have will be a list of product IDs, right? So we're going to have like a list of product IDs. So we're going to have like exactly something like this, right? And then in the query, let me open this. So in the query, what the query will do is find staff from products where ID in. Honestly, that's all we have to do. And then that will return all the products we need at once, instead of having to make multiple trips to the database, thereby increasing the latency, right? And then we can now iterate through each of those products and then map them to the necessary items, right? Honestly, that's how I think I should have handled it, but I didn't. So yeah, so basically that's it for the cart service. What else do we need to check? I think that's pretty much it for the source. I think we've checked every single thing in the source. I think the last part I would then talk about or show you guys is the tests I wrote. Um, all right, so let's quickly check these tests. So yes, if you take a look at my tests folder, so I have a test folder, and what we have there is integration and unit tests. Now, let me quickly mention that when it comes to integration and unit tests, a test being integration, because I've asked myself that question, is okay, why, how do you know if this test you're writing is integration test or is unit test? Honestly, I've come to the realization that it depends, right? Something being an integration test is relative, right? So integration means that you are putting together multiple units and you're testing how they work, right? And unit test means that you are taking a single unit, right? And that single unit can still be an integration test because it can comprise of multiple subunits, right? So honestly, I don't think there's a hard and fast rule to saying, oh, this is integration test, unit test, right? So yeah, let me know if you have a question actually. So yeah, so inside the unit test, let's check unit tests. So in the unit tests, you can say I have mocks. I use this to create a mock user repository because I did not want to. I think I didn't want to create a user on the database actually. So let's figure that out actually. What did I do? So the auth service. Oh, I see. So for the auth service, yeah, so that was what this one was for. So you can see what I did here. User repository that is being passed into the auth service, right, is the mock repository. But then if you check the actual auth service doesn't have to know, right, exactly what is coming in, right? It just needs to know that, okay, it's a type of this user repository. And if you check this mock user repository, where is it? Right, is implementing the same interface as user repository. That is why it worked. I think, although I think what I should have done here is I, my cap wants to remove I user repository and not just user repository. So it makes sense to do this actually. Quickly, let me mention this. So if you check this auth service, you see that I wrote this code, initialize and do event handlers, right? So I have event handlers. So when someone registers, where is it? So when someone clicks forgot password, for instance, we have to send that person an email, right? So I emitted an event, right, with this argument. And this code is just initializing those event handlers, right? So to declare that whenever we have this event, this is what we should do, right? So just quickly wanted to mention that. All right, so basically you can see, right, we are initializing the everything we need and we are passing it in here. This is another advantage of dependency injection, right? We can inject a mock version of anything, right, as long as it implements um, the same interface, right? Also, one other thing I would do differently is you see this bcrypt service and this JWT service. I don't think it's necessary to have like separate services for these two things, right? So I think maybe I would have preferred to create like an helper service that basically has like the functions that we have here. So that helper service would be more of a generic service that stores anything that helps us to do certain things. So yes, as you can see, we have an authentication service test, and yes, this is for hold on. Oh, this is for user login, and I think that's the only thing I wrote here. Wow. Okay, I thought I actually wrote something more comprehensive, but at least I wrote something here. I think the whole idea here was to just showcase the fact that, oh, I can write tests. So I think maybe because I didn't have enough time, that was why I wasn't able to actually like maybe go on, because I think I would have preferred to go on. I can't remember, but yeah, I was able to do this. So I used I used expect to check everything. So you can clone the code to take a look at exactly what I did. And if you have any question, please, you can reach out, right? All right, so the same thing here. Hold on. Yeah, so let me quickly mention this before all. It's like a hook in Jest, and I think it's available on if you use Mocha also. It basically runs all this code, right, before every single test case here, right? So there's also before. Before is scoped, is has a smaller scope than before all. Then for user tests, for the user service, right, we did the same thing. We passed a mock user repository, and then yeah, so we have get user by ID, get user by email. That was all I wrote actually. Um, yes. If you have a question about unit test, please let me know. There's something I want to check. Okay. Yeah. If you have any question about unit tests, please you can let me know. And see, one nice thing about this is that I can also test for the type, right? The instance of the response. Remember, I returned the login response details, so I could also like test that. All right, so that's that for unit test. And what I did for integration, no, don't move anything. What I did for integration tests, you can see I tested auth and cat because that's basically like the main endpoints we have or I had. So you can see um, okay, so this one actually connects to the actual DB. That's one thing, right? So when it comes to the integration test like this, you can either, I think it for integration test, it makes sense to connect to an actual database, but usually it's a separate test database, not the same database that you use in production or you even use for the normal development. So yeah, that's one thing I would have done differently here. Just have a separate DB um, for tests. So what I did here is yeah, I have to clear everything in the database, right? You remember this user, right? So yeah, first, then I think it should be yeah. After all, okay. Once I'm done with everything, right? Then that's what this after all is for. Whenever I mean, once it's done running every single test, it destroys that user, right? So I can see, as you can see, this is just we mocking an actual request and testing the response that gets back. So we have different test cases. That's one thing about tests. When you're writing tests, make sure to go to cover every single test case. So in this place, I have when everything goes well. I have when email already exists. I have when the display name already exists. Those are things. These are things I actually like tested for or I checked for. I also have like when there is a bad request where with something wrong, something is wrong with the payload. So you can see I had all those things. The same thing for forgot password. I had a lot of um, test cases, and then yeah, you can see the same thing for this one. Reset password. Yeah. Then for the cards, right? For the cards, okay. Before I mean because to make a request to that card endpoint, right? We need like a token, right? So I needed to generate one, right? So and this is before each, yeah, before each, right? So before each of these cases, right, it generates a token, right? So yeah, so this should add. This one is for adding product to cart, and yeah, I have the payload. I sent it. It should try an error if product does not exist. So see, product does not exist. You try an error if period ID is missing. You try an error if quantity is invalid, right? Hold on. Oh, okay. Now this is based on this only worked right based on the fact that hold on. Yeah, based on the assumption that you would have run these seeders, right? Because this product ID of one, right, it would only exist, right, if you run the seeder. And one thing I will do differently is that because tests should be independent, you shouldn't have to say that, oh, run the seeders every time you want to run this test. So what I should have done actually here is to create the products here and then destroy them once I'm done creating, once I'm done testing. So yeah, that's just. Then we have get user cards. We have all these things here. I mean test cases. And then yeah, I think I've pretty much like walked through every single thing. Let me see if there's another thing I missed. I don't think so. Yeah. So yeah, guys, I think this has been nice. Oh God, I'm actually very tired. I'm not used to talking for this long. At a stretch actually. So yes, so that'll be all. Like when it comes to like the code walkthrough, let me know. So let me let you guys see my face. Yes, so this is my face again. So that'll be all when it comes to this code walkthrough. Let me know in the comment section if this was fun for you and it was like quite educative. And also, I'm inclined to making more of these technical videos. So please share in the comment section if there's anything you'd like me to make a video on. Then for my next video, I would be sharing a particular story. Someone reached out to me, and I think now I have like 2 people or 3 people that have reached out to me after I released the video about salary negotiation, and the person reached out to ask for my opinion, right, on their particular situation. So I already asked the person if I could share their story, and he was very, very inclined to that. So yes, the next video I'm going to be releasing will be me sharing this person's story and the advice I gave the person. So yes, anticipate that, and please, if you are not subscribed to the channel, please subscribe to the channel. One of my goals for this year is to at least get up to 1,000 subscribers. So I'm really, really counting on you guys to help me achieve the goal. And please don't forget to like the video and also share with all of your developer friends. And I'll see you guys in the next video. Until then, keep believing, keep growing, and keep glowing. Peace.